The only other way, the only other thing you'll see, which might be a little bit more complicated, is if I have a similar scenario here, but now I have someone who's, let's say, pulling some rope upwards. So now this block is being pulled up with 30 newtons. So now we do have some vertical forces, whereas previously we had no vertical forces other than normal force and gravity. Now we have an additional one where someone's actually pulling up on this block with 30 newtons. So the two things we want to find for this problem are the normal force, as we did before, and then we're told find the acceleration in the x direction if the force of friction is considered to be 8% of whatever that normal force you found in the previous part. There is a connection between the force of friction and normal force. You will study that a little bit later in more depth in your physics course, but for now, just understand that the 8% of the normal force might seem random, but that will kind of make sense a little bit later down the road in your physics course. All right, so even though it looks a little bit different, we're going to solve this exactly the same way. If we draw a correct free body diagram, it's going to make our mathematical analysis quite a bit easier. As always, we start with a free body diagram. We know that gravity is always going to be acting on this block. So we have gravity in the downwards direction. In the upwards direction, we have two forces. We've got the force of tension and we've got the normal force coming from the ground. So those are both going upwards. Sorry about that. The normal force and the force of tension are both going upwards. So I have two positive forces in this case. It's not just the normal force. It's the normal force and the force of tension. There are no other vertical forces in this situation. But in the x-plane, however, I have the force of tension. Now, there's two tensions here, so I'll call one Ft1 and one Ft2. So the force of tension, number 2, is acting to the right. That's the 180 Newton force. In the leftward direction, I have 2. We have the 40 Newton force acting to the left. We also have friction. Now I'm going to pause here for a moment because some of you may be confused as to why friction is acting to the left. Well, in this scenario, with the information we're given, it's not always going to be the case, but you can look here and you can say, well, I have 180 newtons to the right, and I've got 40 newtons to the left. If you kind of imagine a tug of war, the 180 Newton force is larger, so it's going to win that tug of war, and that block is going to slide or attempt to slide to the right. Full disclosure, technically it could be either way, but for our purposes, you can always assume, unless otherwise told, that whatever direction there is more force acting in, the force of friction is going to act in the opposite direction. So the reason I use FF to the left here is simply because 180 is larger than 40, so I can safely assume for our purposes that this block is going to want to slide to the right because that's the direction that more force is acting in. So now what I need to do is I need to come up with my F net x and F net y equations. So in the x direction, I have Ft2, that is the only force going to the right. I have two forces going to the left, the applied force and the force of friction. So I'm going to subtract both of those. One rightward force minus two leftward forces. There are no other forces, so I can set that equal to mass times acceleration in the x direction. I could do the same for the y. I have two forces going upwards, the normal force from the ground and that Ft1, the tension of 30 newtons from the guy pulling upwards. Gravity is the only thing going down, so I can subtract Fg. And I've now accounted for all of my forces, so I can set that equal to mass times acceleration in the y direction. To save myself a little bit of time, because I know that this is not accelerating into the air, I know this is only going to accelerate side to side, you can assume that no problems I give you are going to involve the block accelerating off the ground into space. We can essentially assume that that vertical acceleration is 0, so I'm going to kind of zero that out just to save me a little bit of time. Then I can go ahead and plug in my known information. 180 newtons is my Ft2 going to the right, 40 newtons going to the left. Friction is unknown, so I'll leave that as FF. And I'm going to set that equal to the mass of the block, which is 60 kilograms, times the acceleration in the x direction. Now at this point, I don't have enough information to solve the F net x equation because I have FF and I have the acceleration in the x, which are both unknown. But if I solve for my normal force and then use the normal force to figure out what friction is, then I'll have one of these pieces of information and I can solve for the other. So we're going to jump down to our F net y. We don't know the normal force, but we know that the force of tension, Ft1, is 30 newtons upwards. And I can solve for the force of gravity by taking the mass of the object and multiplying it by the acceleration due to gravity. Here I use 10 instead of 9.81. And we know that since it's not accelerating vertically at all, it's only possibly accelerating horizontally, my vertical acceleration is 0. So now I'm able to solve for my normal force here. If I solve this equation, I should find that the normal force is 570 newtons in the upwards direction. I can then on the side figure out that 8% of that value, which is what we were told, if the friction is 8% of the normal force, what is the acceleration? Well, 8% of 570 is 45.6. So I can now go up into my F net x equation. I can plug in 45.6 for my force of friction. And at this point, the only unknown is the acceleration. And if I solve that through, we will find that the acceleration is 1.57 meters per second squared.